So in the last video on inheritance, we looked at, in one of the examples, the idea that you can inherit from a built-in class dictionary. This is exactly that same example where we're making up a tools dictionary. We have a name of a tool, and we have whether it's a hand tool or pneumatic or some other kind of tool, and we have where it's stored, just some kind of weird dictionary. And then we have a special class here, tools, that inherits from dictionary. So it has all the properties of dictionary. It uses the dictionary init method. So when we pass this information into tools, it's actually going to use the dictionary init method because we haven't specified an init method here. And this is going to act just like a dictionary, except for one extra method. Pneumatic tools is a method that we can use to print out a list of all the tools that are pneumatic. So we've extended then the dictionary type to include this extra method. Okay, so hopefully you remember this from the previous. And again, when we print out inventory, when we do this, it's going to say, well, let's see, is there a string method up here? No. So I'm going to go up to the superclass dictionary and use its string method and print out the dictionary so that it looks like this. And then down here, when I do inventory.pneumatic tools, this is actually a method for this class tools, and it creates a list of all the tools that are pneumatic, in this case, jack, and impact wrench. So there you go. Now, what we haven't talked about, because we haven't had to, is that when you create this class and the init method is called, the class has actually already been created by something called a new method. Now we haven't cared about that because the class is mutable, so even though the class has actually already been created, and we can go in and make changes to it using the init method. And if you can avoid it, you're better off not messing with a new method for a variety of reasons. But it turns out that if you're using it in the mutable type, then once it's been created using the new, you can't change it because it's immutable. So when you're using an immutable type to inherit from, or as your super class, like in this case we're going to use a string, which is immutable, then you have to create a new method to create something of type string. Okay, so having said that it's really kind of a bad idea to inherit from a built-in immutable method, even worse than doing it for a mutable type, we're going to go ahead and do it to show that it can be done. We're going to create a new exception. So exceptions are built in classes, and we can inherit from them and create our own exceptions. This is actually a good idea to do that if you are doing some kind of error checking for a class or object that you have, and certain kinds of things are going to raise an error, and you absolutely must have something in your class to satisfy certain properties. So for this case, we're going to create student IDs, and those student IDs have to have certain properties. The first character has to be a capital A, it has to be 8 characters long, and the last 7 things all have to be digits. If it doesn't satisfy as one of those, it's an invalid student ID, and since that's no good to us, then that would be an exception if it's invalid. Okay, so when we're going to create a new student ID, we have to override the built-in new method for the string. Otherwise, it won't allow, it's just going to go ahead and create a string, and we won't be able to do anything with it. All right, so here's how this is going to work. We're going to pass in an optional parameter s, which will be the string, and any extra arguments. There really shouldn't be any, but we'll just throw those there in case there are. If we don't pass in a string, so if we get the empty string, then we're going to ask for a student ID number. And then, based on that student ID number S, we are going to check to see if it is in fact valid or not. If the first character is not a capital A, we're going to raise the student ID error exception and return. If the length is not A, we're going to raise the student ID error exception and return. And then, if those two things are satisfied, we're going to go through the range, so the last 7 digits, apparently I need a space there, And we're going to check to see if we can convert those over to type integer. If we can't convert them, each one of those, to a type integer, that's going to give us a value error. And if we get a value error, we're going to raise student ID error. There's somebody typed in something wrong. We also need to check index error, because possibly somebody will just, when we do this input, somebody could just put in an empty string, in which case there will be no zero index. And when we do this check, this if statement, that would raise an error. Okay, so we'll raise a student ID error in that case. If all of this stuff passes, so we have a valid ID, then we're going to return, and in this case, we want to create a new string. So the superclass for student ID, I'm using a slightly different notation or way of declaring the super than I have in the past. In this case, I'm saying I want the super for student ID, so you can specify the subclass in here. And something I didn't mention is that this is actually a class method. So that's new. This is a method for the class string. So we're going to call a CLS instead of self. And then we're going to say we want then the new method for this class. So this is a class method, and we're going to pass in the string s. And this is going to create for us then a string. And we're going to return that string back. So in Python, if you wanted to declare a string, you could actually use this new, I mean, it'd be kind of ugly and nobody would understand what you're doing, but you could use this new method to create strings all the time. If you want to show off, I guess, how cool you are or something. All right, so let's see how this works. Down here, we're going to try to instantiate student ID, and we're not going to pass anything in. So this is going to be the case up here where we get an empty string, and it'll ask us to input. And then we're going to print out the ID unless we get a student error. And if we get a student error, we're just going to say invalid ID. All right, so let's run this thing. Let's run the correct thing. So it asks us for an ID number, and we hit enter, and that's invalid. So, and that's the case here where it tried to check the first character, and there wasn't one. So that gave an index error, raised the student ID error. And down here in this try except block, it said invalid ID. You can try and type in a lowercase a, and that's the case where we check this first index. It's not a capital A. That raises the student ID error and returns us back, and that puts us in the exception. We can try typing in a capital A with a 1. That's not going to be long enough. So we are going to be in this case right here. And then we could, so we should have 7 digits after the A. And what happens if we put a character there? And that very last one, when it tries to do this int, it's going to raise a value error because it's trying to take the int of s, which doesn't exist. So that'll raise a value error, which in turn raises student ID error, and that exception is caught down here. And then finally, we can type in a valid student ID, and it just prints the ID out because this is, as far as it knows, a valid ID. We probably could check to see if there's a couple of zeros after the A or not. I didn't go to that extent. I didn't think it was necessary. So in some ways, I mean, this works nice now. We have this built-in error checking for the student ID. ID here is going to be a string. It'll act exactly like a string. It's got the same other methods as strings have. But the general idea is you don't want to override that new method unless you have to. It can create all kinds of problems. So even though I showed you how to do it, don't do it.